Hi folks, welcome to 6.1 video part 4. And so in this video, we're going to talk about graphs of cosine. All right. And so we're going to do this in a very similar format that we did for sine. So using Desmos, if you graph cosine, you'll get something kind of like this, right? And so it looks a lot like sine, right? It has the waves, it kind of goes up and down. So it's important that we know the difference between the two, okay? Now, just like before, these waves sort of come up and down, and they keep going in both directions, all right? And so that means that our domain here is negative infinity to infinity. That's still the same, okay? Now our range, I still see that the lowest point is at -1 and all of the highest points are at +1. So my range is still going to be -1 to +1 with the brackets, okay? Now, last time we said that we said that sine was odd. And the reason that we said sine was odd is because it had uh, reflections, symmetry across the y-axis and the x-axis, okay? But even as soon as I draw this y-axis in a little bit darker, I see that the two sides, if I fold them over, are exactly the same, right? This point and this point sort of match. This point and this point match. This point and this point match. And so what we have here is that cosine is an even function, okay? So sine is odd, but cosine is even. Now, what about that period, right? How long does it take to complete one wave? Well, I can start here, go down to the bottom, and then get back to where I started. From 0 to 2 pi means my period is still 2 pi, okay? So a lot of things for cosine and sine are the same. The domain, the range, the period. But the one thing that is different is that cosine is even while sine is odd, okay? All right, so let's ask ourselves the same question. Where does the graph come from? All right, we're going to fill in our favorite quadrantal angles again. Pi over 2, pi, 3 pi over 2, 2 pi. And we're going to fill in our quadrantal angles in the other direction. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And we're going to think back to our unit circle and find the x values for all of these angles on the unit circle. And we know at 0, the x value is 1. And then when we move to pi over 2, we get an x value of 0. And then -1, 0, and 1. And when we go the other way, we get 0, -1, 0, and 1. Okay? So I'll leave that to you to make sure that you're able to figure out where those values come from, right? Knowing how to read that unit circle is super important. But for the meantime, let's go ahead and plot those points. So 1, 0, -1, 0, 1. And then same thing in the other direction. And then when we connect them, we end up with exactly, or almost exactly, what we had when we plugged it into Desmos, right? This picture in the red is pretty much the same picture that we just drew right here. So where did we get it from? Short answer, we got it from the unit circle, okay? All right, so graph transformations, gonna be super, super similar. We've got A, B, C, D, and we're gonna want to do the C first, and then B, and then A, and then D, okay? So let's get this all on one page so we can just take a look at that. And then in part 5 of the video, we'll go through a couple examples of the cosine graph transformations, okay? Going to be pretty much the same, except it's just a different parent function. So we just got to be careful which one we start with, all right? So I'll see you back here.